Hello, good day. Welcome back to Coding with V. And today we're going to jump into episode 6 and talk about RAG. Now, what is RAG? RAG stands for Retrieval Augmented Generation. I know it's quite a mouthful, but don't worry about it. We're going to break it down. So, without further ado, let's jump in. So usually when you open, let's say, Msty, you would select a model that you want to use. And then you'll type a prompt. And in this case, let's say the prompt is it's just instruction to the model, whether that instruction is to answer a question for you or tell you some fact or something like that, or the instruction is for it to generate something, like maybe generate a poem or something like that, or to verify something, or summarize. We haven't looked at all these different examples, but these are all things you can ask the model to do, right? It's an AI model. So if it's a general model that's trained on like text generation and chatting, you can do these things. Proofread something for you, that sort of thing, okay? So you send your prompt to the model, and then the model thinks about it for a little bit, processes it, and then output the response. So why would you want to use RAG? Well, the model that you're using was trained on some data that has a cutoff date. So anything that happens after that cutoff date, the model won't know about it. So if your model, let's say, was trained on data up until 2024, for example, or the beginning of 2025, and let's say in this case, where I'm at now in May, we have a new pope. So the model wouldn't know who the new pope is. If you ask the model, simple fact, who is the pope, the model would answer with, answer that's incorrect. Would provide an answer that's incorrect because that's the information it has. Well, RAG is an attempt to fix this. So the way RAG works is you still have the model. You're going to still provide the same prompt, but instead of the prompt going straight to the model, it goes to a database essentially. And we're not going to worry about a type of database or any of that stuff. In the next video, I'll talk a little bit about that. So we're just going to say somehow Msty is going to take your prompt and use it to go retrieve some information from a database that Msty manages and get extra information. Now, what is this database? This is a database of more updated information. And again, we're going to leave out the details of how you populate this database with more current information, but it is additional information that the model wasn't trained on. And then you can think of a new prompt, I'm going to call it prompt star, is created. This prompt star includes your prompt. Your prompt has not changed, but appended to your prompt is also this additional information that came out of the database. And this combined information, or this combined new prompt, is sent to the model. So now the model has your prompt, some extra information, and it can still have access to its own information. And now it's going to be able to think about it for a little bit, and then, well, not a little bit, take for as long as it needs. But then now the output should be better because the model was augmented with new information. So that generated output was augmented from data that was retrieved from this database. So hence RAG, Retrieval Augmented Generation. And so hopefully now you can see why it's called RAG. Now, let's see an example of how you would use this in Msty, or how Msty supports RAG. So here I am in my command line, and I have a data directory for episode 6. And basically all I have is, let's do tree, and I have some files. So I have estimate.pdf, which is just a PDF file with the tree estimates. I showed that in the last video. I have a comma separated value file called also transactions, which I generated from an LLM, but I'm not going to show you that today. But it's pretty straightforward. Just ask LLM to generate some data. And I have some user.json data, which I generated here at Mockaroo. So if you've been following me for a while, I've shown previously when we work on web application how to generate data, sample data. So I went to Mockaroo and just essentially says generate data, save this as, and you can choose where you want to save it as JSON, comma separated value, whatever. So now that I have that data, let's go over here. Here's that household data that's just show basically transactions for some household over essentially a year from January to December. And you can see some of the charges were made with a credit card, a debit card, and certain things that were purchased. And then this user.json, it just, you can imagine, I have users who have signed up and I have their name, email address, gender, and maybe the IP address from where they connected. Okay, so that's my data. And I'd like to be able to provide this or save this in some sort of database, but into a database that Msty can use, so I can then use an LLM in Msty to get information about this data. Let's now go to Msty. So I go here to knowledge stack. Notice I already have a knowledge stack created because it takes a few minutes, and so I want to speed things up. I'll show you again how to create a knowledge stack, don't worry. Now, the other way to get to knowledge stack is just simply by clicking here and then click manage knowledge stack, and you get the same thing. So let's say I want to create a new knowledge stack. So I'll say new knowledge stack. I'll give it a title. So I'll call it episode 006, and let's call it, how do I want to create the embedding? Embedding is how it's stored. In the next video, I'll talk about embedding and explain what is going on. You can try the other ones. They'll provide different features and capabilities, but for now, let's just stick with this one. I find Nomic embedding text to be the fastest. Well, for what we're doing. And then you just click add. And now that you've created a stack, but it doesn't have any information, you can add now a folder with these type of documents. You can add notes, you can have YouTube links, or you could just drop the files here directly. So I will just drag and drop these files that I showed you into here. Now let me just move that back off screen. And so it's my episode 6 data and the same files that I showed you. And now I can say save as a draft, or I can say compose. Compose is essentially indexing that data, basically taking it, processing it, and putting it in a format where it can later be retrieved. So this is the thing that can take a few minutes, depending on the type of data that you're composing or putting it in your stack, and the type of embedding model that you're using. So if I click compose here, and there's some change settings that you can make. So for example, you can even though we selected no embedded text, you can splitter type, and this tell you what a splitter type, what a splitting means, and it talks about chunks. Again, we'll ignore it and just simply, let's just do sentence, and we'll do high chunk size, and we'll just leave it for that, like that. And then I'll just click on compose, and it's going to process. Now, notice how it quickly processed the PDF document. But if you just simply change the model that you use for the embedding and you do the same exercise, you'll see it'll take different time. So just keep that in mind. And you can see now it says completed and ready to chat. Now, episode 6 other and episode 6 both stack contain the same files, as you can see. So I can use either one of them. But there's no point in me having episode 6 other, because again, the exact same thing. Okay, so now that we're composed and we're ready to chat, we can close this window. So we want to use the information we just created in our stack. Now we know we can do that by clicking here, selecting the stack we created, and this similarity, for now, let's put it to high, which means that when we search for something, we like the highest possible match. And for number of chunks, I'll increase it to 60 for now. And I'll explain in the next video why it is, and I'll show you why. But this video is already too long and it's going to take a long time to sort of justify it. So just trust me and do that, at least for this example. So you have the exact same data because you can go to GitHub and find the exact information. I'll commit it. Now let's ask a question. Let's say, how many times did I go to did I dine out? Let's see. I have not tried this yet, so let's see. But let's go to our data and see if we can answer this for ourselves. So if we look at the data, find dining out, yeah, right there, dining out. Okay, dining out. So 2 of them. So 2 occurrences of dining out, $45, and here for $80. So let's see. So I'll close this and go back here. And so it says, I have no way of knowing how many times you've dined out. Interesting. Because we just saw that there are 2 records, but let's see what it found. It did find some data in our stack. And specifically, it found that there's an entry for dining out on New Year's Eve, which we saw, and it says a similarity score of 57. So that's, not very high, but, it found it. So I'm not sure why it still said, it didn't find anything about dining out, even though there's clearly at least 1 record there. What about if we change the model? All right, delete this one and create another conversation. Let's use Mistral, Nemo, and again, the same stack. And I'm going to send the same question. How many times did I dine out? But what we can tell is it is picking up the information. So it's searching our stack. What seems to be wrong is the model is unable to understand the question and come and derive the answer from the data. And there's something we haven't covered yet, and it's how capable the models are. And this is going to vary by model size and type and training and what they're trained on, a whole bunch of factors, the quantization, which we haven't talked about. So none of those things we've talked about. So it's quite possible that the result we're getting is because we have very small models. So we could try a larger model, but of course that's going to take a longer time to process. But this is the trade-off that you make with, running very small models on your machine. They're interesting, but sometimes they don't perform as well. Now, granted, there are a number of small models that do perform very well for their size, but there's something that you should keep in mind. If you're not seeing the result that you expect, try changing the model. So that is why you see that I have so many different models, because when I do pretty much anything, I send it to a few different models from a few different creators and try to compare and then compare the result. Anyway, so let's see. Hopefully our Mistral Mino is going to come back pretty soon. It's taken quite a long time. I don't know why it's taking so long. Look at this. The same question, different model. And notice it says, you went out twice on New Year's Eve, which we saw. And it says for pizza. And if we look now at the result, we can see that, this looks like it's just showing one here, but somehow it picked up both of them, even though it's only showing result for one. So let's see if that's correct. It says second pizza night, dine out. Sure enough, there we go. All right, second 14. So this work, and this is exactly what I was saying, that just simply changing the model give us the result we want, whereas the Gemini one, for whatever reason, didn't give us the result. So this video is already quite long. Play around with this. You can check out Git repository and get the same files and play with them, try your own files. But as you can see, we're able to use our data and ask questions, and it worked. The problem, the caveat, is maybe the model you have might not work the way you think, so do try different models. That's it for this video. I've waited until the end to ask you to subscribe to the channel if you're not already a subscriber. I want to thank you if you're a returning subscriber. Thank you for sticking with me and supporting me. I really, really appreciate it. I can't thank you enough. If you find something useful in this video, please give the video a thumbs up. If there's something you think I could have done better, you have questions or you have suggestions, or you're going to be doing something else, just drop it in the chat. I do read the messages. I don't have quite enough time to respond right now, but I will respond pretty soon. And stay safe. See you in the next video. Bye.